Hello, this is the fourth video on multivariable calculus. In this video, we're going to talk about another object in three-dimensional space. This video is about lines in space. So a line can be determined by one point and a direction vector. So oftentimes when we think about lines, we think about 2 points and a line going through these 2 points. However, a better way of thinking about lines would be to say they contain a point, let's say we call that P0, and then a vector that is parallel to the line. So if we say a point P equals x comma y comma z is on that line, for the line to be parallel to the vector v, we need to have the vector P0P to be a scalar multiple of v. When we write down P0P, we get x minus x naught, y minus y naught, and z minus z naught, and TV would be TA, TB, and TC. So setting the equations, setting these to equal, we get x equals x naught plus TA, because this one has to be equal to that, and then y equals y naught plus TB, and finally z equals z naught plus TC. This is called a parametric equation for the line L. Now, there is another way of thinking about lines as well. If we solve this system of equations for t, from the first one we get x minus x naught equals TA. The second one gives us y minus y naught equals TB. And the third one gives us z minus z naught equals TC. Now, dividing by a, we get x minus x naught over a equals t. And y minus y naught over b is equal to t, and z minus z naught over c is equal to t. So that means these three are equal, and that gives us what we call symmetric equation of a line. So x minus x naught over a equals y minus y naught over b equals z minus z naught over c. Now the next thing is the vector equation of a line. So what is the vector equation? This is also pretty useful to know. So vector equation is thinking about the line as a vector. So the position of every point on the line is x comma y comma z. So we're going to replace that by x naught plus ta, y naught plus tb, z naught plus tc. So we're going to separate this. This gives us x naught, y naught, z naught plus t times a, b, c. This guy is one point on the line, and then this one was the direction vector, so t times v. So vector equation of a line is given by r of t equals r0 plus t times v. r0 is a point on the line, the position vector of a point on the line, and v is direction vector of the line. Okay, let's do an example here. So find a parametric equation of the line passing through these 2 points. So in order to find equation of a line, we need two things. We need one point on the line, and we need a direction vector. So we are given, in fact, two different points on the line. So how do we get a point on the line? Well, that is given. How do we get the vector parallel to the line? That would be AB. You could use AB or you could use BA. It doesn't really matter. Both of them are going to work. So the vector AB would be terminal minus initial, so -1, 2 minus 1, and then 3 minus 1. So that would be -2, 1, 2. So that's the vector parallel to the line. So then what's the parametric equation? It would be x equals, y equals, and z equals. What we do is we write down the point. We could take point A or point B. It doesn't really matter. We could take 1 plus t times the coefficient right here. So -2. And then 1 plus, so we take this one plus coefficient times t, and then again 1 plus coefficient times t. So this is called the parametric equation. So parametric equation would be x equals 1 minus 2t, y equals 1 plus t, and z equals 1 plus 2t. Okay, let's do one more example on lines. Find a symmetric equation for the line that is parallel to the given line and it passes through this point. So we have a given line, this is the line that's called at L, and we have a point 2, -1, 1, and we want to find a line that is parallel to the original line L and it goes through this point. So how do we get that? So again, in order to find the equation of a line, we need two things. We need a point on the line. Well, we are given that point, that is the 2, -1, 1, and we need a vector parallel to the line. So now, given the symmetric equation, x minus 1 over 2, y minus 1 over 3, and z, those three are equal. What is a vector parallel to that line? Well, the vector parallel to that line is the denominator, so 2, 3, and 1. But we gotta have to make sure that the coefficients of x, y, z are 1, and in fact coefficients of x, y, z are 1 in this equation. So we have x here, y here, and z. If it were not 1, if the coefficients were not 1, we would have to turn them into 1. So that means the vector parallel to the line would be 2, 3, 1. They asked us to find a symmetric equation for the line. So what we do is we do x minus y minus equals z minus. So on top we put the point. The point is 2, -1, and 1. And at the bottom we put the direction vector. So 2, 3, 1. So this is a symmetric equation for the line. Okay, so the next thing we're going to talk about is the distance from a point to a line. So imagine you are given a line L, which again means you are given one point on the line, and we have also a direction vector. And we are trying to find the distance from a point P to that line. So the question is, what is this distance? So let's call this distance D. Okay, so here's what we're going to do. We are going to use this right triangle. So let me call this vector P0P, and then I also have the direction vector of the line. Let's call that vector V. What is that distance? If we use that right triangle, we get sine of theta times hypotenuse. So P0P times sine of theta. So just to remind you, sine of theta appeared in the cross product. So the cross product of A and B, the magnitude of that was magnitude of A, magnitude of B times sine of the angle between two vectors A and B. So if you want to find the product of one vector and sine, we'll have to do cross product of P0P and the vector. What is the vector in the direction of L? That is V. And then we have to divide by magnitude of V. And that's the formula for the distance. So the distance formula from a point P to the line containing P0 would be magnitude of P0P cross V divided by magnitude of V. So it's a useful formula. So as you see, I have the formula right here. Okay, so in order to find the distance from a point to a line, we need to find two things. We need to find a point on the line, and we need to find the vector parallel to the line. Now, the point on the line could be any vector, any point on the line. And the vector parallel to a line could be any of those vectors that are parallel to a line. So any vector or any of the multiples of that vector. And we would always get the same answer. Okay, so let's look at an example. Find the distance from this point to the given line. So the first thing we need to do is to find the point on the line. Now, what would be a point on this line? Well, it is any xyz that satisfies this equation. It doesn't have to be any specific one. It could be anything that satisfies this. The easiest one is the point that makes this equal to 0. So if x is 1, y is -1 and z equals 0, we get that all these three things are 0. So in other words, the formula for equation of a line was x minus x naught over a equals y minus y naught over b equals z minus z naught over c. So these numbers 1, -1, and 0 are going to give us a point. But again, this is just one point on the line. You could choose any point on the line. What is the point that we are given? Well, that's 1 to -1. And then finally, what is a direction vector? Well, the direction vector is when we write down this as x minus something over a, y minus something over b, and z minus something over c. So how do we do that? Well, the first two terms are already in that form. The last term should be written as z minus something over some number. Well, the coefficient here is -1, so we'll have to put -1 at the bottom, and of course this would have to be 0. So v would be 3 to -1. So these are going to give you v. Next, we're going to evaluate the p0p. I'm using the formula, which is terminal minus initial, so it's 0, 2 minus -1, that's 3, and then -1 minus 0, so that's -1. And then we'll have to find p0p cross v, which is evaluated by a determinant. So I, j, k, 0, 3, -1, 3, 2, -1. We'll evaluate this, find the magnitude, and divide by the magnitude of v. So this is I times, we'll have to evaluate the determinant of this. So it would be 3 times -1 minus 2 times -1 minus j times, we'll have to eliminate the second row and the first column, so we get this. So we get 0 times -1 minus 3 times -1, and then plus k times, we eliminate the first row and the last column. So if I were to point out to what we're evaluating, it would be this one. So 0, 3, 3, 2. So we'll have to evaluate that. So this is going to give us 0 times 2 minus 3 times 3. So let's evaluate this. This guy would be minus 3 plus 2, so that's minus I. This guy would be -3 times -1, that is 3, and then we have a negative sign, so -3j. This guy would be 0 and then -9, so -9k. So the distance is going to be magnitude of this quantity minus I minus 3j minus 9k divided by magnitude of the direction vector, which is 3 to -1. Okay, so this is going to be root 1 plus 9 plus 81 divided by root 9 plus 4 plus 1. So this is root 14 at the bottom, and the numerator is root 91. So this is our distance. Okay, so let's do one more example. Show that the lines given by these are parallel and find the distance between them. So how do we check when two lines are parallel? Well, the easiest way would be to look at the direction vectors, the vectors that are in the directions of the two lines, and show that these direction vectors are in fact parallel. Or in other words, these direction vectors are scalar multiples of the two, each other. So let's find the direction vectors of L. So vector parallel to V is, what we do is we have to look at the denominators, 2, 3, and the denominator of this one. However, we'll have to first write it down as z minus something over something. So that would be z minus 0 over -1. So the direction vector here would be 2, 3, -1. And this is to vector parallel to L. The next one is vector parallel to K. So what is the vector parallel to k? We'll have to look at the coefficients of t in the parametric equation. -2, -3, and 1. So we get -2, -3, and 1. Now if you look at these two vectors, these two are scalar multiples of each other. 2, 3, -1 is in fact negative, -2, -3, 1. So what does that tell us? This tells us that either the two lines are parallel, so either L is parallel to K, or the two lines could also be identical lines. So it's not quite telling us that the two lines are parallel. It's also possible that the two lines are exactly the same as each other. Okay, so we have to also show that the two lines are not the same as each other. Now there are two ways of showing the two lines are not the exact same thing as each other. What you could do is you could take one point on the first one and show that that point does not satisfy the second one. That's one way. Or better yet, you could use the fact that the distance is not 0. So we'll find the distance and then we're going to show that the distance is not 0, which means the two lines are not also identical. So let's do that. That's easier because that would be solving the second part of the problem as well as the first part at the same time. Because the two lines are parallel, we could take one point on one and find the distance using the distance formula that we just learned. So what is the point on line L? So we know that one point would be 1, 0, 0. Those are obtained by setting all of these three things equal to 0. So x equals 1, y equals 0, 1, 0, and z equals 0. P0 would be a point on the second line, and that would be 1, 2, 0. So that's 1. And the direction vector here was -3, -2, -3, and 1. So we're going to evaluate P0P. So P0P, we'll have to subtract P0 from P. So terminal minus initial, so that would be 0, -2, and I believe 0. And the vector is -2, -3, 1. So we're going to evaluate the distance between these two by finding the cross product, which is I, J, K, 0, -2, 0, -2, -3, 1. So we get I times, eliminate the first row and the first column, we get -2 minus 0 minus j times, eliminate the first row and the second column. So we get 0 minus 0 plus k times, eliminate the first row and the last column, we get 0 minus 4 because it's minus 2 times minus 2. So we get three negative signs, which would give us -4. So that's -2i and then minus 4k. Then we take the norm of that, magnitude of that. So the distance is going to be magnitude of this, -2i minus 4k, and then divided by magnitude of -2, -3, 1. Let's evaluate this. This is root 4 plus 16 over root 4 plus 9 plus 1. So what does that give us? That gives us square root of 20 over square root of 14. So this is the distance. So now, in addition to finding the distance, we know that since this distance is not 0, L is not the same as K. So therefore, L would have to be parallel to K, and the distance is what we found. The distance is root 20 over root 14. So that's our final answer. So to summarize, this is what we talked about. We wanted to find equation of a line. We need one point and we need a vector parallel to the line. And this is called a direction vector. To find the symmetric equation, we write down x minus x naught over a equals y minus y naught over b equals z minus z naught over c. To find a parametric equation, we do x equals x naught plus at, y equals y naught plus bt, z equals z naught plus ct. And to find a vector equation, we do r of t equals r0 plus tv, where R0 is a point on the line. To find the distance, we have a formula. We find one point on the line, we find a direction vector, and then we use this formula to find the distance from a point P to the line containing P0 with direction vector V. So I will see you in the next video.